Hey, what's going on, folks? It's Mike here, and welcome back to my Deep Programming Language series. In this lesson, we're going to go ahead and talk about how to copy a class. And because a class is a reference type here, we need to talk a little bit exactly what that means, and we'll go ahead and see, are there things like copy constructors for classes? Well, little surprise for you if you're coming from the C++ world, there are not copy constructors in the traditional sense that you'd have. And again, we want to talk about why that exists and why it makes sense in the deep programming language. So anyways, with that said, let's go ahead and dive in and we'll continue our discussion about classes. Make sure you checked out the previous videos. If you haven't, again, you can check out courses.msha.io and follow along in the deep language series to track your progress otherwise. But anyways, let's go ahead and go to documentation, the language reference here, scroll down to classes. And if I just do a Control F for copy here, okay, there's something about copying fields, some notes about, something that's equivalent of doing some sort of copy, and then copyright here. Okay. So basically, that's the short of saying, if I look through here, I'll find constructors, which are sort of a special member function, and destructors, another sort of special member function here. But I don't see copy constructors or anything like we might expect there. Now, again, if you've been following this series, and if I scroll to the bottom or jump back to structs and constructors and search for copy, you'll see for structs, we have copy constructors that we can define, okay? If I look at a struct copy constructor, I'm going to see I can do pretty much the same thing or something similar to this idea with classes. But again, I have a reference type here. So we got to be really explicit with what it means to make a copy of some sort of reference type here. Because part of the point of a reference type is that I can just reference it from many different places and not have to make copies, okay? So that's where I can get a lot of speed here. So let's go ahead and demonstrate just a few of these ideas here and just jog your memory here. So let's just go ahead and create some dynamic array, which is a reference type here, okay? And I'll do 1, 2, 3, 4, something like that, 5. And let's just go ahead and print it out so we can see what we got here. 1, 2, 3, 4, 5. It's probably going to be useful too if we print out the address of this. So address of this. And to do that, we use the format specifier %x here. If I want to print out this address, well, let's go ahead and jog our memories for how we do that here. I mean, let's just go ahead and put this object in here, right? That's just going to print out the object. So yeah, it didn't really do the right thing here. And I also need to, here, let's make sure we do formatted line here. There we go. And this should complain at us. Yep. So I want to get the actual pointer of this thing here. Oops, let's go ahead and try that again. RDMD. Let's run this. Okay, and I've got the address. Okay, so here's the thing, the object I allocated. I've created this sort of slice in the first, slice of this type here. So I need to create this here. Okay. Let me go ahead and just demonstrate here. If I create some new slice here, and I set it equal to the dynamic array reference type here. Let's print out the new slice. Okay, new slice here. And let's go ahead and do the same experiment as we just did here. So new slice here. Okay, and new slice. Address of new slice. Okay, so let me go ahead and comment out line 12 here. And again, the first thing that you need to see here is, yeah, if I go ahead and create this new slice here, and again, let's not hide behind auto. I know folks like to be explicit, so let's just make it, exactly what it is, a dynamic array here. It is the same thing here, right? Now, if I print the address of my new slice here with right format, you will see here, now if we carefully look at this, 73 AEF, and then 31, 31, followed by a bunch of zeros, right? So it's the same memory. And that's part of the point of reference types. We can get a lot of speed by doing this. So for example, if I'm passing this into a function, let's call this foo here. Let's pass in another, slice here, or dynamic array here. And all I'm going to do here, all I care about is printing out the address here, address of, let's call this function slice here. Function slice, okay. Function slice, func slice, something like that. And let's actually call it again. So let's do foo Let's pass in our dynamic array reference type, and let's run it. And let's again see that, if we carefully line these up here, no matter where we are referring to the same memory right here, okay, wherever this, initial memory was allocated. So that's a great thing. Reference types aren't to be hated. We just have to know how they work. In fact, they can make our code very, very optimal because we're avoiding copies, okay? And that's sort of the whole point here. But you're watching this video because you want to learn about how to make copies of classes. So let's go ahead and talk about that. So I'm going to go ahead and just comment out this experiment, and we'll start from scratch again. But let me go ahead and type out the point here. Point of reference types is to make things fast. We get to avoid making copies all over the place here, okay? And we do have a note. Remember, we do have the ref keyword for working with structs, okay? To help us avoid making copies, okay? So just keep that in mind here. Again, because we talk a lot about, now that we've been talking about classes, the differences between classes and structs. But again, you came here for classes, so let's go ahead and just kind of restart here. Let's create a class. I'm going to create Mario, like in Super Mario or something. I'm going to give it some fields, X, maybe that's like the X position across the screen or something. And just something similar here, some data. I don't know, maybe we're recording the positions of where Mario was over time here. In fact, let's call that positions here, okay, just to be explicit. Now, what I'm going to want to do here is let's create a constructor here, and it's just going to take in a initial X position here, something like that. And let's go ahead and push that position into our positions array here. Okay, just so it has some data, okay? Because I'm going to want to print out the positions. That's why I'm doing this, okay? Otherwise, if I have nothing to print out, it's not, useful. It doesn't allocate this thing, so the object could be null, and we'll run into problems when we print things out. But anyways, that's enough for us here. And then our destructor doesn't really need to do anything, right? So if you're watching our last video, this is some reference type. This will be garbage collected and just taken care of. Okay, so we don't have to worry about that. So again, that's a nice thing here. But I do want to write a little print function here in the same way that we were printing out the addresses below here. So let's do write formatted line here again. X is format specifier for X address, %X here for that. So let's do this.x and the address of X here. Actually, I don't even need this here because it's not ambiguous. Let's print out positions. So let's delete until, oops, the end of the line here. I'll just go back here. Positions. Okay. Just because I want to give us something kind of nice to look at here. Positions. And then I actually want the address of the position. So positions address here. Address, can we fit it all? Yeah, I think so. And I want to put in %X. This one actually just needs to write out the line. There we go. And we want positions, the pointer. Okay. Now, again, why am I going through all this trouble for setting this up? Because I want to be able to just like debug a little bit here. And see when we create a class here if we're working with a copy and confirming that we're making a copy or not. Okay, so let's go ahead and proceed forward here. So let's create an instance of Mario. I'm just gonna call this M1 here, and this is a new Mario, and the position, 57 here. And let's go ahead and do M1 print, and let's see how we did here if I rerun this code. Okay, so I've got my new Mario here. It's got an address. We've got our positions, one that I've pushed into our array, and then the address here. Okay, so let's go ahead and create a second one, Mario 2. Let's go ahead and just increment this here. Oh, there we go, Mario 2. I'm just going to give it a unique, again, position here and print it out. And here, let's make our life just a little bit easier here. Just give it a right line. Okay, just between them. Okay, so two different objects, right? Because we've used two different news. allocating two different types here. So nothing, crazy about that. If we're using structs or classes, right, we're getting new objects, no problem there. And we can see that they're different. The dynamic arrays are different, and so on. So now let's make a copy here, or attempt to make a copy and see what happens. Let's go ahead and do M3 here. Okay. So if I wanted to do M3 and do something like this with the assignment, okay, let's see what happens. And again, Mario M3 reference type, it should be identical to M2. And it is, right? It's setting up everything in the exact same way, but that's because it's pointing to the same memory. Okay, so this is not a copy. Okay, so this here, this is not a copy. This is just using the reference semantics, okay, that we showed down here. Okay, where I said, hey, if it's a reference type, it's just going to refer to the same memory. Okay, so that was the idea here. Okay, so with that said, how do we make a copy here? Well, there are a few different things that we can do here, and we've actually looked at these before. So let's go back to this experiment just to bring you way back here. Let's have an array here equal 1, 2, 3, 4, 1, 2, 3, 4, 5. And if I want to create a second array here, array 2, I can use dup here. Okay, so dup, short for duplicate. Okay, and then we have idup, short for duplicate, but it's an immutable copy made. Okay, so an immutable duplicate here. Okay, so for these ones here, if I write out the address, so address, let's do address of array, %x here. Okay, just as a quick example, and then we'll do it for the class here, for our array. Let's go ahead and do array 2. And let's run this here. Oops, let's see here. Now what did I do here? Well, I tried to print out the object here. I need the internal pointer here, right? So that's what I want here. And we should be able to see pretty clearly. Again, it's so fast to compile, it's better to just take the time to add that one tiny space there. But hopefully you can see in this little experiment that we did where we used dup that was a way to return a new copy here, okay? So you could use that convention, okay? So the point of this experiment, and let me go ahead and just highlight here. The point of this experiment was to show you a convention for copying a reference type here, okay, using something like dup. Okay, so no problem there. So let's go ahead and do it. Let's go ahead and write a dup function here. Now, what would dup need to give? Well, I'd say it's the type of whatever this object is, right? We don't want a concrete type here. And then just call it dup here, okay? And again, if you don't like this type of, right, just to demonstrate everything, right, you would just say this is Mario. Okay, that's the same exact thing that I just did there. So, but I like using type of this just in case I change the name here. I only have to do it one time. Okay, so you'll see that in a lot of generic code. That kind of happens here. So I can write my dup function that would basically create a Mario, new copy here, and then you would just implement your copy. Now, why do this? Okay, you implement your deep copy as needed, right? So if you have to run a tree traversal algorithm or individually copy all the elements of an array or some data structure, that's why you write this dup function here, okay? Because it's reference type and we need new memory here, okay? So this is our new copy here. So let's make sure we do new Mario. And that's what I want to return here, right? My new copy here, okay? Allocate it. So allocated in the garbage, in the, deallocator, allocated in the allocator, allocated, let's just put it here, and will be, GC'd eventually, garbage collected. Or again, you can go back to the previous video where we talked about destroy and all those sorts of things here. So now I just need to do my new copy.x equals, this.x. new copy dot positions equals this dot positions dupe. Okay, same little example that I showed down here where you want to duplicate the array, right? So somebody else has already written that function here to do the deep copy and make sure we allocate memory and so on. So that's just a function that's returning us the right block of memory here. Okay, so let's go ahead and try this now to see if we get a copy here. So let's go ahead to our little experiment here. Let's call this Mario M4. This is going to equal, I'm going to pick on this Mario here still, M2, but I'm going to call a dupe on it. And then I want to do my M4 dot print here. Okay, so I'm expecting M4 will have the same value, 59 here, and then that one value pushed into positions, but the addresses should be different, okay, if I've allocated my memory correctly. Okay, so let's go ahead and run this. Oops, let's see here. Little mistakes here at 13. Let's see, this is saying that a found new, did I mean Mario, blah, blah, blah. Let's see. Just missing a equal sign. All right, always a little bit anticlimactic when there's a small mistake, but that's live coding. And let's see, line 50. Let's see, function declaration without return type. Of course, probably forgot on my, let's see here. Return, just a silly error here. Let's make sure we do this within our main function. There we go. And one more little snafu here, so to speak. At line 13, we don't have an empty constructor, so I could provide one if I want here, or I should probably just use, this one would be fine here. And that'll actually be a little bit better here. I can get rid of this line here. So let's just construct it using this.x here. We'll just pass in there. Okay, there we go. All right, now do we see what was expected here? Let's go down to the code here to our Mario 4, which is created by duplicating M2. So x is 59. We're getting the same value, but at a different address, same positions, but stored at a different address, so it is somewhere else in memory. So that's a good thing again. All right, so there you go. You wrote a function to make a copy. Again, if you were in like C or the better C mode of the D language, for instance, you would just do this. There'd be no problem with this. But by convention, you can use dupe or idup. And idup would just return immutable in front of this, right? You'd make this an immutable object, okay? So that would be the idea here. Now, one thing that you could do also stylistically, if you just wanted to, you could create a constructor that took in some other Mario class type here, and I'm saying pass it in const because we don't want to modify it here. And let's just call this the right hand side, and this would be constructing a new object from some other object. So I kind of like dupe here because it's greppable. So I'll just put a note here. I like dupe because it's very greppable to make copies from. Okay, so that's kind of nice here. And it's just very, very clear what's being done here. But stylistically, if you want, you can create this type of constructor to match what you're used to in C++ or something, right? I could do this here. And this would instantiate my new object from the right-hand side, right? So it's already building it. So I do this dot x equals right-hand side x. And then I would do basically this same thing here. I'd say this dot positions equals right-hand side dot positions dot dupe. And that would pretty much do the trick here. Okay, let's go ahead and try that out here. So let's go ahead and do a Mario M5. Let's create it from, let's make a new Mario, but we're going to instantiate it from M4 and M5. We'll do the print here. We'll run it. And again, we'll see that M5 gets the same values as our Mario 4 here, 59. Different addresses for all the fields, which implies we did the right thing here. And again, just like a little correctness thing, you would still do the classic like C++. You would just say like if I would actually make this like an assert. Maybe I would say assert this is not equal to the address of the right-hand side here. Right, and we would say no point in copying same class object or something like that. Okay, let's see if that does the trick here. Let's see here. Okay, but I'm actually not going to go down this rabbit hole of overloading because we haven't talked about operator overloading. But again, you do that sort of same thing here where I need to figure out how do I know if these objects are equal, right? If they're pointing to the same address, basically. So anyways, I'll just get rid of that. But you got the basic idea here. So you could check if, so optional or to do, check if object is a copy of itself. What do I mean by that? Well, you'd sort of add this circular situation where you'd say like Mario m6 equals m5, and then you try to construct Mario m6 equals new, let's see here, like new Mario m5 or m6 for that matter. Okay, so that's the basic idea of what you want to prevent there. But anyways, folks, hopefully that makes sense here. I mean, this gives us two sort of tools here, right? A constructor that populates the fields here from another object. So again, doing the deep copy here. It does the dupe here as needed here. I mean, the other easy thing you could just do here for this is to just go ahead and say this equals, actually, let's try this right-hand side. Let's just make a duplicate here. And I need to return to this object here, but let's see what happens here. Right, so I need this reference. Let's see, we need to dereference this object here. No, that's not gonna let us do it. All right, but anyways, I'm not gonna mess around with that too much, but basically we could save ourselves some of this initialization code if we wanted, and just like return the object and assign it to each of the fields here if we had to do some complicated algorithm, right? Because we might not necessarily want to you know, re-implement all this logic here. So I could just create another Mario object inside of this. That's a dupe of the right-hand side, right? So I could just do, again, Mario object equals right-hand side dupe. Let's see if that works here. Okay, so that works. And then I would just go down each field and assign it to whatever this object is, because you already have a copy. Okay, so again, you can use, that's again why I sort of like implementing this dupe here if I'm going to make copies of things if I'm using classes here. Okay, alrighty, so a quick review here because we talked about a bunch of things here. We did, again, a little reminder here of reference types, why we like them, because again, they help us make things fast. We don't have to make copies, that's all the point. But on occasion, you do have a class type or some hierarchy, some deeply nested hierarchy perhaps, hopefully not too much inheritance or something. But occasionally you do want to make a copy here, so you can check to make sure that copy is available by just printing out the addresses of things. It's a good way to verify. But I like making just a little dupe function that can do the work here. And then of course, if you want to provide a constructor that takes in a type of the object, again, you can do the same trick here that I showed here where I do type of this here just to make it a little bit more generic in case you rename things or whatever. You can do that. But anyways, the point is that you would just for each field run whatever algorithm you need to make a copy of things here. So not too bad overall, just something to remember, and sort of again to remember the why here. Again, I wasn't around when D was first developed, but I suspect, again, with languages where you want things to be fast, you want to avoid copies. This is where we get the really, really nice slicing stuff here, which again, if you're coming from like a C++ world, that's like everything is kind of like a span if you're passing in arrays or those types of data structures, or you just have the option for your type to be reference type. So it's a little bit more to keep track of, right, versus languages that just have value types only. But you can potentially always get this sort of like free speed and not have to worry about copies and that kind of stuff here. But that said, sometimes you do want to, you know, avoid making copies and you don't need to, but again, you can be explicit with dupe here. So anyways, I'll go ahead and leave it at that. Thank you for your time and attention, folks. Hopefully you're enjoying these lessons as we dive into classes here. I mean, the basics of classes are relatively simple, so you don't really have to remember like too many rules. You can just use them as is, but we're going to do a deep dive here for those of you who want to know how things work, maybe why things work, and just see some more examples beyond what's in the documentation. So anyways, folks, thanks for your time and attention. Let me know if you have other ideas of ways or cool tricks that you do with your classes, or things to look out for. I'll be looking out for those in the discussions below. And otherwise, I'll look forward to seeing you in the next lesson.